we want to use our table feature on number 2 to see what the limit is as x approaches -1. So I'm going to go to y equals. Go to my table. I want to start at -1. So at -1, I see an error message on there. That means there's a point of discontinuity here. We know it's not a jump because that's not a piecewise, is it? Look at me. Look. We know it's not a piecewise. But let's look at that. Do you think it's removable or infinite based on?
Removable.
Okay. Through here. If I factored this here, that'd be x minus 2, x plus 1, wouldn't it? Could I cancel the x plus 1s out so it's removable? Do y'all see that? Okay, what's a good value that I could say is approaching?
-0.33.
I'll take that. Next, let me show you. I just have my eyes set on -0.32. That's fine. Okay, just somewhere close to that, okay? What I'm mainly concerned with is how you do it from the graph, okay? So let's look at, is everybody good on those? Let's look at number 9. The limit as x approaches -1, is that to the left? Yeah, to the left. -1 to the left. As I come from the left, what value is it approaching? 2. Do y'all see that? Alright. Here, as I go from the right, what value is it approaching? 2. Now, this says the limit as x approaches -1. When they don't have a sign, you're fine, buddy. You're fine. When they don't have a sign after, that means you got to look at it from the left and the right. Well, I kind of just did that in these two, didn't I? Do they both have the same value? So, does it exist? Yes, it's 2. Now, guys, I got to ask you a question. What if I asked you for f of -1 here? What would you put for f of -1? 1. You would put that. F of -1 is 1. Alright, now I want the limit as x approaches -4. Okay. They do not have a little plus or minus afterward. That means you got to check both sides. So coming from the left, what is it approaching?
4.
It's approaching 3. Coming from the right, it's approaching what? 4. Is it approaching the same number? So what is your answer? Does not exist. The limit is x goes to 4. Goes to 4. From the left, it's approaching what value? From the right, it's approaching. So what is it? Alright. Number 11. Does that mean the limit as x approaches -2 from the left? What would that be? Very good. Reese, as the limit as x approaches -2 from the right? Very good. So what would be my overall limit as x approaches to -2, Taylor? Very good. Now we want the limit as x approaches -4. Okay, so I got to check both sides here. Okay, so that one's going to that's going to which side, which number? 2, and from the right it's going to what number? 3. So what's your answer? What's the limit as x approaches 3? -2, because you're going -2 from both sides. What if I asked you for the value of f of 3? What would be f of 3? -3. Are we good on that? Do number 12 right now. Huh? On which number? Oh. Oh, gotcha, good. Alright, what's the limit as x approaches 2 from the left? Conlon? Very good. Josiah, from the right, what is it? Very good. What's your overall limit, class? 2. The limit as x approaches negative 4. This, you got to take upon yourself, check both right and left. What would that be, Zach Rogers?
Negative 4.
Look at D. It's approach, okay. It's approaching what y value? Sorry. What is it? 0. Very good. Alright. E. As x goes to 5. Max? Very good. Are there any questions on how to look at a table or graph?
No.
Okay. Now, let's turn to page 3 in your notes. Today, we're going to look at how to do this algebraically when just given the problem. Okay. And this is what you'll be doing a lot in calculus. What? What did you do? Okay. Alright, techniques for finding limits. Try direct substitution first. That's always your first line of defense. You're going to try direct substitution. If that doesn't work, then we're going to factor. And if that doesn't work, we're going to rationalize. You know, we have rationalize the denominator, but sometimes you might need to rationalize the numerator. So that's going to be a new vocabulary. So you might have to rationalize the denominator or numerator. Okay, so first thing you do, guys, look at number 1, the limit. The limit, x goes to 5 of x. You just take that number and plug it in. What does that give you? 5, that's your answer. He said, is it that easy? Sometimes it is, but this is how you know direct substitution does not work. That's called direct substitution. Taking the number, plug it in. Now let's look at 2. As x goes to 0, if I put when there's a fraction, what you do is you plug it in the denominator. If it makes it 0, then you need to try a different technique. Direct substitution is not going to work. So whenever you plug 0 into something and it makes it not work, or 0 comes out in the denominator, if 0 comes out in the denominator, then you can't do the direct substitution. You're going to have to try to factor or rationalize, okay? So here, that's a prime example. I plug 0 in. Oh, it doesn't make it equal to 0, does it? So this is a direct substitution. You can do direct substitution. Okay, I plug 0 in.
Also factor it.
Yeah, with the plus 5 and minus 5.
That'd be easier.
Well, let's see what we get. We'll do it both ways. But plug 0 in. 0 minus 5 is negative 5. Negative 5 squared is what? Negative what? 25. Very good. Plug 0 in. 0 squared minus negative 25. What's 25 divided by negative 25? Negative 1 is your answer. Alright, y'all want to see, let's factor first, okay? If we factor that, that's going to be x minus 5 times x minus 5 over x plus 5, x minus 5. Yep, that worked. You can do that. Alright. Number 3. I'm going to try direct substitution first. Take 1, plug it in. What's 5 times 1? 5 minus 4 is? 5 minus 1 is? 4 square root of 4 is? 2. There's your answer. Direct substitution works on that one as well. Limits are easy when direct substitution works like that. Let's look at 4. If I take, now here, Fraction got my attention here. I take 5. 5 squared is what? 25 minus 25 is? I'm going to say hold up now. Bless you. Hold up now. I'm going to have to do something. This is where I would factor, okay? I'm going to try to break it down. So that's be x minus 5 times x minus 5 over x plus 5, x minus 5. Then I'm going to cancel, remove. Once I remove all I can do, then you try direct substitution again. Okay? Once you clean it up, you try direct substitution again. If I put 5 in the denominator here, 5 plus 5 is what?
10.
I didn't get 0 in the denominator, okay? 5 minus 5 is? 0 over 10 is what? 0 is your answer. Now 0 can be your answer. It's just, you got to do it, you're cleaned up first. Let's look at number 7. Try direct substitution. Is there any place where I can plug a 2 in?
No.
So what's your answer?
Well,
Very good. Next. Alright, let's look at number 5. I got a fraction that makes me nervous, so what I'm going to do is try direct substitution. I'm going to plug negative 2 into the denominator. Let's do this. Negative 2 to the 4th is 16. Negative 2 cubed is negative 8 times 2 is negative 16. So 16 and negative 16 is 0. That's gone. 4 times negative 2 is negative 8. Negative 8 plus 8 is 0. So I have 0 in my denominator. So I need to try another technique. So I'm going to try, what would you do? Rationalize or factor? Factor. Try to factor. So I'm going to group on top. Take it out of x squared. That leaves me at x plus 2. Take a 3 out. That leaves me at x plus 2. Bottom, I'm going to take an x cubed out. That leaves me at x plus 2. Now I'm going to take a 4 out. That leaves at x plus 2. So I have x squared plus 3, x plus 2 all over x cubed plus 4, and x plus 2. I can cancel out my x plus 2. Now I'm going to try direct substitution again. I'm going to plug negative 2 in here. Negative 2 squared is 4. 4 plus 3 is 7. Negative 2 cubed is 8. Negative 8 plus 4. I didn't get 0, so I'm good. Negative 8 plus 4 is negative 4. So your answer is negative 7/4. These are your most basic limits. Now, throughout the rest of the unit, we're going to be studying. There won't be a number here; it's going to be an infinity. So, how do you handle infinities? Or it's going to be just to the left, to the right. All right, number 6. What's my first line of defense, guys? Direct. If I plug negative 1 in here, am I getting 0 in the denominator? No. So I can do direct substitution on this one. All right. So negative 1 squared gives me 1. That's plus 2 minus 8 over 1 minus 4. That gives me negative 5 over negative 3, which is equal to 5/3. That's the value it's approaching at negative 1. That's not bad, is it? Okay. Let's look at number 8. What type of function is this? Piecewise. Okay, the limit of f of x as x approaches 1. Which of these pieces would 1 fall between? Which? First, middle, or last? Where was 1 fall in my domain over here? First, okay? So x less than 2, I plug 1 in. What's 1 squared? 1, that's a negative, because that negative says negative 1 plus 8, which is what? 7 is correct. That's your answer. I plug 1 in here because it's less than 2. 1 squared is 1. Negative 1 plus 8 is 7. Now I got the limits x approaches 2. Okay, which one would you use, the first or the middle one? Middle one. What's 2 times 2? 4 is your answer. 4, which one would you choose, middle or last?
Middle.
2 times 4 is? There you go. Direct substitution worked on all 3 of those. Alright, let's look at number 9 here. The limit as x approaches 9. I'll take 9 and I'll plug 9 into that denominator. That gives me an undefined situation, doesn't it? So you can't do direct substitution here. Can I factor anything in this problem? Can I factor? Yeah or no? No. So I got to use my other technique, rationalizing something. Well, it's in the numerator, isn't it? So this is a case of rationalizing the numerator. So I'm going to multiply the top and bottom by what? Square root of x what? Plus 3. Very good. Now watch this. Square root times the square root gives me x. This times 3 would be plus 3 square root of x. Enter. Negative 3 square root of x. Negative 3 times 3 is negative 9. All over x times square root of x is x square root of x. X times 3 is 3x. Negative 9 times square root of x is negative 9 square root of x. Negative 9 times 3 is negative 27. On top, I can clean this up. I'm left with x minus 9. Alright, I'm going to try direct substitution. Let's look at the bottom here. I'll plug 9 in. Y'all help me keep this straight because there's a lot going on right here. What's square root of 9? 3. 3 times 9 is, so I'm going to write a little 27 over there. What's 3 times 9? 27. I plug 9 in here. What's square root of 9? 3 times negative 9 is what? So that cancels out one of these positive 27s, don't it? And this negative 27 cancels this other one out, don't it? So I'm back to where I'm started. I got a 0 in the what? So I can't do this. I got to think, okay, what can I do? Well, I've already used my rationalizing, so I'm going to try to factor something here. If I look down here, I could do grouping, but let's see here. Take a X out. Do you think we need to move some stuff around? I kind of would want to get these square root of x's together and then get that 3x and negative 27. You can do that, can't you? Sure. Yes, you can. So, now I'm going to group. What can I take out of this first parentheses? Then I can take a what out over here? So I'm left with x minus 9 over x minus 9 and square root of x plus 3. Here's Mr. Fisher. I would not have thought to do that. I would have factored as if it was right here. Well, once you started factoring, you'll realize that it might not work and you would then rearrange it, okay? Now, what can I cancel out here? These x minus what? So I'm left with 1 over this. Now let's plug 9. Let's try direct substitution now. What's the square root of 9?
3.
What's 3 plus 3? 6. It didn't give me 0, did it? So my answer is 1/6. We forgot our trivia quiz, and no one was going to remind me.
Can we just wait till tomorrow?
I mean,
Wednesday.
Yeah. I only got 2 more examples. Don't worry, we'll get done. Number 10. Let's look at number 10. The limit as x approaches 3 of 1 over x minus 1 over 3 x minus 3. Number 10. First thing, line of defense. Try direct substitution. I plug 3 in. What's 3 minus 3? On the denominator, give me 0. So can I do that technique? No. Can I factor anything? Can I factor anything? No. Can't rationalize anything. So what do you think we need to do here?
Does not exist.
We don't give up in the face of fear. Okay. What's in the numerator? We're subtracting what? So we need to find a common what? Common denominator. So let's go to the side and find a common denominator. We have 1 over x minus 1 over 3. What would be my common denominator there? 3x. Make sure you understand how I got 3 over 3x minus x over 3x. Is everybody good there? Find a common denominator. Alright, so I get 3 minus x over 3x. Now I'm going to take that and put that back in the problem. That's still a complex fraction. I'm going to come to the side over here, guys. And I'm going to write out what that means. That means that divided by that. Well, you can change that division to what? Now I got 3 minus x and I got x minus 3. We talked about this last year now too. Those are almost the same, but they're not, are they? But these are the opposite. I mean, both of them are switched, aren't they? Could you still cancel those out? Yes, but what do you have to put in place of it? -1. You remember that? You can cancel those out, but you got to leave it, make something a negative. So I'm going to cancel those out because I can do it because these x's are opposite, these 3's are opposite. I'm just going to put a -1 right there. -1 over 3x. Now, I'm going to try direct substitution once I've done all this work. My x value is approaching 3. If I plug 3 in there, am I getting 0 in the denominator now? No, so what's your limit equal to? -1 over 9. Alright, number 11. The limit as x approaches 0. If I take 0 and plug it in my denominator there, guys, is my denominator undefined? Is it undefined? So can I do direct substitution here? So can I factor that? Can I find the common denominator? So what I'm going to have to do, rationalize the what? Numerator. I'm going to come to the side here and rationalize it. Before you're going to add 2. Now you're going to FOIL. Now let's look at this FOILing here. When I multiply this times this, what happens to those square roots? They do what? Cancel. Hey, Dr. Mosley. Good. Alright. Now, x times this will be just x square root of 4 plus x. X times 2 is plus 2x. Now, I'm going to clean it up a little bit. These go away. What's 4 and -4 do? That goes away as well, don't it? So I'm left with x over x square root of 4 plus x plus 2x. Now, I'm going to plug 0 and see what I get here. 0 plus 4. Alright. 0 plus 4 is 4. Square root of 4 is 2. 2 times 0 is 0 plus 0. I still get 0 in the denominator, don't I? So what can I do in the denominator? What can I do here? Do they have something in common I can factor out? What do both this term and this term have in common? X, exactly. So I'm going to factor x out on the bottom. And when I do that, guys, these x's cancel out. I'm left with 1 over square root of 4 plus x plus 2. Now I'm going to try that direct substitution again. I plug in 0. 0 plus 4 is 4. Square root of 4 is what? 2. 2 plus 2 is? Am I good now? So your answer is 1/4. Your limit. That's as hard as it gets. Is that too bad? Huh? Oh, are you kidding? Alright. I need a hand signal. Can you determine a limit algebraically now? So we learned 3 things. Table, graph, and algebraically, okay? Is everybody good with that? Let's do a checkpoint and a trick quiz.
What is a trick quiz tomorrow?
Yeah, we're doing it now. Let's review for Zach. What is the ordered pair for a 30-degree angle? 30 degrees. Square root of
3 over 2,
comma,
1/2.
pi over 4,
Square root of 2 over 2.
60. Write your name when you get this. That's not showing. Yours is in the screen. Write your name on it.
Craig is like the worst thing ever in that.
It's easy if you ever learn it. Start.